In today's lesson, we want to look at a ZIMSEC question. It was written in June 2003. Saka ndo question yatinayo iyi. Chatanga taita A, tozoita B, tozoita C. But what we are going to do is chatanga tabvisa part ke A kuitira kuti take konzeva our space, tozobvisa part ye B, then lastly tozoita part C. So just a piece of advice, it's very important to take note of the number of marks. My general rule is a minute a mark. Kureva kuti if a question is 3 marks, you should strive kuita in under 3 minutes. Kana tora more time, you can add plus or minus 1 minute. Kuitira kuti mukwanise kuita your examination in the stipulated time. So that is the question. 3 marks. Evaluate the summation of 2r minus 3 from r is equals to 1 up to 200. So how are we going to do that? Chekutanga question yatakati tinofunza. You have to ask whether you are dealing with an arithmetic progression kana kuti a geometric progression. In order for you to know that is it an AP kana is it a GP, you need the first few terms kana kuti first few numbers in the sequence, and typically we only need 4 numbers. So how are we going to do this? Chekutanga, we are answering A. Tichati kana r ari 1 tokunotonyora kuti when r is equal to 1. When r is equal to 1, what is going to be the value of the first term? So if you remember from our earlier class, takati the notation un inoreva kuti kudini, inoreva kuti the nth term. That is what this notation refers to. Saka u1 ingechireva kuti chi first term, u2 ingechireva kuti second term, and so forth. Saka kana mfunzo wedu ndewe kuti kana r ari equal to 1, what is going to be the first term? Notation yatoshandisa for first term ndi u1. Saka u1 inge iri equal to 2, then to substitute r unoina 1, so 2 times 1 minus 3, which is 2 minus 3, and the answer is minus 1. Kureva kuti kana r ari equal to 1, and when r is equal to 1, the first term inge iri minus 1. Then the other question we ask is, when r is equal to 2, the second term is equal to 2 multiplying 2 minus 3, which ultimately is equal to 4 minus 3, which is 1. And it. So this is the answer we are getting here. This is the answer we are getting there. Tovatati, when r is equal to 3, the third term is what? 2 times 3 minus 3, which is 6, and minus 3 indian. What is 6 minus 3? The 3. And then lastly, when r is equal to 4, the fourth term is 2 multiplying 4 minus 3, which is, what is 2 times 4? That's 8. 8 minus 3, 5, 6, 7, 8. So it's equal to 5. Saka panapa manje, we can write this down. Tinenge takuti the sequence, and so let me write it here using a different color. The sequence is, then our first term d minus 1, our second term d1, then 3 apple, then 5, tot, and so forth. But kana muchida yenyu, you can write it like this: minus 1, 1, 3, 5, and so forth, up to what? Up to 2 multiplying 200 and minus 3. Saka it's minus 1, 1, 3, 5, and so forth, up to upper it's 400. From 2 times 200, that's 400. Subtracting 3, it's 397. That is going to be the last term. So last term iyo taiwana say tatora the expression 2r minus 3 tika substitute r with 200. Since taudzwa panapa, if we are to interpret information yatinayo inoindo engerishi lower bound kana kuti lower limit, inoindo engerishi the upper bound, and kana kuti upper limit, like this. So that is what we are working with. So it's either mnongoti and so forth to avoid the error of misinterpreting kana kuti ill interpreting the information. Like a common mistake here would be kuti -1, 1, 3, 5 and so forth up to 200. This would be a common mistake. If you watch our first question yataka answer under series and sequence, you will learn why that is a fundamental error of principle. So let me remove this part. I hope kuti ma understand out first term, second term, third and fourth to know what I say. So let us remove this part so that we can reinterpret this part properly. Truda mbonyorei. Truda kunyora kuti the sequence andika sequence anti -1, 1, 3 and 5 to that and so forth up to what 397. Is this an arithmetic progression or it's a geometric progression? So kana tichida chokutanga, you can actually investigate this on your own. 1 minus -1, that is 2. 3 minus 1 di 2. 5 minus 3 di 2. Saka tiri kuona panapa kuti we have a common difference. Common difference which is denoted D takati iri equal to preceding term minus preceding term. Saka the preceding term panapa ngari 1 subtracting the preceding term ngari -1 tiri kuona chi 2. Saka 2 is the common difference. We can make a conclusion, therefore the sequence is an arithmetic progression, like this. That is what the sequence is, an arithmetic progression. Saka taziva kuti our sequence is an arithmetic progression. Answer yedu kana kuti question yedu iri kuti evaluate. Saka tiri kunzi titsvage a summation kana kuti the sum of 2r minus 3 with the values of r being from 1 up to 200. So the two methods we are going to employ panapa, tinofangwa kuziva kuti what is the sum of n. Saka sum of n kana tiri ku arithmetic progression ingeri equal to n over 2 yobva yati 2a plus n minus 1d, or sum of n ingeri equal to chi n over 2 yobva yati chi a minus l, and toziva kuti a inenge chirepresenta chi the last term. So that is what we learned in my formulas. They should be second nature to us. So I wanted to confirm panapa it's actually plus, and so it's n over 2 2a plus n minus 1d, or n over 2a plus l. Okay, saka we have our formulas properly. What then are we going to do? Tukutsvaga the sum of n. Saka in our case, and we are going to do both methods, kana magona kuinterpreta this sequence, especially kuziva kuti the last term is 397, you can easily use this second formula. But kana manga msina kudaro, you can equally use the first formula. So toda kushandisa both the first and the second formula toona kuti inobuda answer here. but you have to pick your poison. You have autonomy on which methodology you use in your mathematics. But if it were up to me, I would encourage and advise kuti mushandise the first formula. Yakareba hayo, but it's a make sure. Because mukaita mistake ya yekuisa 200 panapa, the second formula won't give a correct answer. Okay, so let us do this. We are going to have our method 1. Then next to it, we have our method 2. So for our method 1, tirikuti, the sum of n and is equal to. So when we are now applying this formula, we have to understand. What should we understand? Let us just have a rundown of what we have done so far, so that we can add on to what we have to do now. So we are given the series from r is equals to 1 up to 200. What is the sum of 2r minus 3? So the first step, we did determine the first few terms of the sequence with the view of establishing the type of the progression. We asked ourselves, is it an AP or a GP? After evaluation, we discovered we are dealing with an AP. As such, the progression is arithmetic in nature. Our first term is -1 and a common difference of 2. Now, we want to evaluate, because question yati evaluate this summation. Tikaona since it's a summation, zvoreva kuti tiri kunzi titsvage sum of n terms. Saka, you can actually take it as some form of a trick. Trick yacho ndeyekuti questions on evaluating a summation are questions on sum of n terms. You have to know that. Then maziva izvozvo manje, let me bring it down a little panapa. Takuchida kuevaluate that sum of n terms is equal to n over 2a plus n minus 1d. Do you know that n should actually be the upper bound? And because itaudzwa kuti from r is equals to 1 up to 200. Saka n yedu is going to be the upper bound. Kureva kuti panapa inenge s of 200. Because tiri kubva pa 1 tichienda kuna 200. How many terms do we have? We have 200 terms inside this sequence. So Sn, n yacho is 200. If you go back to our first lesson, to learn kuti n ino representa chi, and pataiti the nth term. Takataura pamusoro pe rank, position in a sequence. So how many positions do we have? Kana tichibva pana r is equals to 1, tichienda pana the upper bound yedu iri 200. Zvoreva kuti tikati 1, 2, 3, 4, 5 up to 200, we have 200 terms. That's why tichiti s 200. So I want you to pause here and ponder. So azviri kureva. If you compare this question with our question 1, question 1 yedu yaitova na n as the upper bound. So it was more like self-explanatory. Question imanje, the trick part ndeyekuti vati r is equal to 1 as lower bound. Ndekuzoti our upper bound ndi r is equals to 200, even though isinganyorwe like that. Saka Sn zvinongoreva kuti S 200. This is very important. So S 200 iri equal to chi. This is equal to pana n 200 over 2 like this. Then to over 30, 2 times a, that's 2 times minus 1. Our first term plus panapa it's 200 minus 1, multiplying a common difference of 2 like this. So if we evaluate this, tinosara tina 100, up it's minus 2 plus 199 being multiplied by 2. So let me use my calculator to make this evaluation. So ndichangozvinyora sezvo zviri in my calculator. 100 multiplying -2 plus 199, which is multiplying 2 like this. The answer is 39,600. As simple as this. Okay, let us see kuti iyi inobuda here, which is a method number 2. So for our method number 2, sum of 200 inenge iri equal to 200 over 2. Our first term is minus 1. Our last term is 397. And let me confirm this. Yes, 397. Like this. So this is also 100 from 2 into 200. Multiplying minus 1 plus 397 is basically 396. And 396 times 100 gives us 39,600. Inobuda futi. Saka iyi method 2 chekutanga kunzwisisa kuti SN should be S200. Kana musana bata that part, please tell me in the comments so that I find a way of explaining it again. Then the second tier, method 2 is dangerous if you cannot evaluate kuti the last term is 397. Because last term tunoiwana by taking the upper bound 200 into 2r minus 1, is it? Then we evaluate kuti tiwane the last term. So that is very important. It was 2r minus 3. Very, very important. But ndo mawekero atinoita e. You either go by the first method, which is using the long form sum of n terms method, or the second method, which is using a short form, but you should be able to evaluate what the last term actually is. I hope you understood this part of the question. I want to take us to the second question so that we can continue with our work. The second question should be evidently more difficult because in a 6 marks, according to our 1 minute 1 mark rule, Zorewakuti should do it in under 6 minutes. Dzikawandisa dzifanirwe kudarika plus 1 or 2 minutes. Kureva kuti either 7 or 8 minutes kana dzatowandisa. But because in ndiri and explain, of course, I'm going to take a little more of your time. So looking at B, so when we look at B, due to the fact that the progression and B achirumboti kudini, let us read the question. Find the least number of terms. The least number of terms. And saka it's number of terms. Satenda kure. How do we find number of terms? For which the summation of 1 over 3 to the r from r is equals to 0 up to n differs from its sum to infinity by less than 0.001. Mapon. So we want to find the least number of terms for which that summation differs from its sum to infinity by less than 0.001. So our step 1 panapa, of course, imika namchinyora yo exam amuti step 1. Step 1 ndiye kuti question yedu iri kuda kuti ite evaluate the summation. That's our step 1. Taita evaluate the summation. Step 2 iri kuda kuti tiite sum to infinity. And lastly, step 3 iri kuda kuti tiite find the difference. Ndozvingori papa. Mapaona. Ndozvingori po. Saka toda tanga taita evaluation. Then from evaluation tozoita sum to infinity. Then from sum to infinity tinenge takuta se takuzoita that difference. Then we make our conclusion. But what's important is there's a Q per question. Q yacho nde E, sum to infinity. patakadzidza zvinhu takati sum to infinity inongowanikwa chete kana iri geometric progression. Saka tatoudziwa kuti that thing is geometrically progressing. But even though tinofanirwa kuita that process of trying to evaluate whether it's a GP or AP, so that we find the first few terms and potentially the last term. So tiri pano manje tinenge takuti when r is equal to 0, because r arutangira pana 0, our first term u1 inenge iri equal to 1 over 3 to the power 0, which is what? Just 1. And it? Kana r are equal to 1, then which is u2 now, the second term. Murikuona zviri kuitika panapa, because r is equals to 0 first term, so that r is equals to 1 is second term. This is equal to 1 over 3 to the 1, which is simply a third. Kana r iri equal to 2, the third term is a third squared, which is 1 over 9. And lastly, kana r are equal to 3, the fourth term is a third cubed, which is 1 cubed into 1 over 3 cubed, 9, 9, 18, 27, like this. Kureva kuti the sequence is 1, a third, a ninth, and a 27th, and so forth. Of course, panapa, we know from our mathematics that our last term is going to be a third to the power n. But ndoda kukuyambirai, kuziva last term is not that necessary, because tine imwe formula yai. Mapona. Saka kuziva last term is not that necessary. But taku GP manje. Taku GP. Tinowana say common ratio. Common ratio inge equal to a third over 1, because it's proceeding term over preceding term. So this is equal to a third dividing 1, which is simply a third multiplying 1, which is a third. Mukazvitarisisa 1 times a third into third. A third times a third into 1 over 9. 1 over 9 times a third into 1 over 27. So this is our common ratio r. Saka taziva kuti common ratio ndi r, a third, tikaziva kuti our sequence is a GP. Okay. Let us now see what we can do panapa. Toda kutanga taita our first step, which is to evaluate the summation. So when we want to evaluate the summation, and candida is so panapa. It was unnecessary though. Saka sum of n kana iri GP ingembori equal to chi. We know kuti inge equal to a 1 minus r to the n over 1 minus r, like this. Those are inge equal to a 1 minus r to the n over 1 minus r. But tikada kuva technically correct, because n should represent the number of terms in a sequence. That is what n represents. Tikatarisa in our question, tinoona kuti we are not starting from 1, we are starting from 0. Saka we have 0, r is equals to 0 ndo inenge iri first term yedu. Kureva kuti kana takuda kuevaluate panapa, zviri most correct kuti the sum of n plus 1. And let me take your time explaining this, because it might be a confusing phenomena. In actual terms, tinofanga kutoda iso. Tinofanga kunyora this statement. Kuti the summation, and it from r is equals to 0 up to n of a third to the power r is equal to the sum of n plus 1. Reason iri kuti, because tikutangira pana 0, tawedzera a term. That is the same reason why panapa tachiti r is equals to 0, tachiti the first term u1. R is equals to 1, the second term u2. Mukatarisa kwa example yedu yekutanga, andika munoona patanga tichi evaluate panapora itapabvisa. Tanga tichiti tikati r is equals to 1, tanga tichizoti u1. Tikati r is equals to 2 tachizoti u2. But in this instance r is equals to 1 and it's actually u1. R is equals to 0 it's u1. R is equals to 1 it's u2. Saka tawedzera a term because tikutangira pana 0 kuverenga not pana 1. That is the reason why it is sum of n plus 1. So zoda tambwa nazo kuti zvinzwisisike. I really hope kuti manzwisisa. Saka taita this evaluation manje. The sum of n plus 1 inenge equal to chi. Inenge yava equal to, since the sum of n is equal to a1 minus r to the n over 1 minus r, the sum of n plus 1 inotichinje zvishoma. Inenge iri equal to a haichinje 1 minus r pana n parikuenda chi n plus 1 over 1 minus r, like that. Ndo change inoitika. Saka manzwisisa hero nemakaita ati sum of n plus 1 instead of sum of n, because hatisi kutangira pana 1 tutangira pana 0. Saka we have to count r is equals to 0 as a term. That is why we did that. So taita seizvo manje, how are we going to evaluate that? Saka it was not necessary pano kuti tiwana our last term, because kana tiri ku geometric progression tingori ne one formula chete sum of n terms. Hatina formula inoita account for the last term. So that was just extra pudding, which was of non-effect, a non-effect actually. Saka panapa when we want to do the evaluation, let us do it tuone. So our evaluation tingeta kuidai, so this is equal to, what is the first term? D1. Tovatati 1 minus, what is r? R it's a third. Ta evaluate, remember. So it's a third to the power n plus 1, like this. And this is over chi 1 minus, what is r again? A third. Saka let us evaluate this. So this is then equal to, panapa it's 1, panapa ita 1 minus a third to the power n plus 1 over, itikainyora is 3 over 3, tinoona kuti pasasapa ingetori 2/3, like this. Andika? Saka taona kuti i 2/3 like that, tinogona kuita sei. What if we rationalize? Kureva kuti tinenge tichi multiplier kuzasi kunoku na 3 over 2, kumsoro uku na 3 over 2. Kureva kuti 2 iya kuchekana ne e, 3 ya kuchekana ne e. Saka our final answer inenge iri actually 3 over 2 times 1, which is 3 over 2. 1 minus a third to the power n plus 1. Tinogona kuita yakadai so. This is our answer. That's our answer. Anditi. Saka step 1 pakadai so inenge yatopera betunana. Step 1 inenge yatopera. Okay. What about step number 2? Step 2 tati, we want to evaluate the sum to infinity. Saka sum to infinity ngatingoitry paside panapa as our step 2. Saka sum to infinity tinoziva kuti iri equal to a over 1 minus r. A wedu ndi 1 over 1 minus our common ratio, it's a third. So this is simply 1 over 2/3, which is 3 over 2 after evaluation, like that. So data step 1 yekuti it evaluate that, and trick iripo kana tina r is equals to 0 mufonga kuichenjerera. Tikaita step number 2. Step number 2 ndiyo yekuevaluate sum to infinity. But if we go back to our question, tisati step number 3 yekutsvaga the difference. Zvanzi, find the least number of terms for which that evaluation differs from its sum to infinity by less than 0,001. Kuroti kana tikada kuimathematize that statement tinenge tichiti find the least number of terms for which this evaluation differs from its. Saka evaluation iyi ndio iri kuita differ from a sum to infinity. Ndikati find the number of which 3 differs from 8. Handiti zvandiri kureva in essence ndiri kuti 8 minus 3. So zviri kuitika apo tikada kuimathematize inge iri sum to infinity like that, subtracting the sum of n plus 1, it should be less than 0.001. Find the least number of terms for which that evaluation differs from its sum to infinity by less than 0.001. Saka the sum to infinity subtracting the sum to the evaluation sum of n plus 1, and it should be less than 0.001. Saka tichidila ne this hypothesis panapa zvatenge takuita sei. Zvatenge takuita panapa tenge takunyora this statement: the sum to infinity subtracting the sum of n plus 1 should be less than 0.001. Then sum to infinity taona kuti it's 3/2 and subtracting, then the sum of n plus 1 ndiyo yataona kuti ichi. So that's 3/2 minus 3/2 multiplying 1 minus a third of n plus 1 less than 0.001. Saka patatora the sum to infinity taona kuti pata calculate yabuda iri 3/2. Then the sum of n plus 1 taona kuti irichi minus 3/2 bracket of 1 minus a third of n plus 1 less than 0.01. What's intelligible panapa? We have to collect my numbers kuside rawo ega. So it becomes 3/2 subtracting 0.001 less than. Then since up are negative, kuenda kuside kunosvika iri positive. So it's 3/2 1 subtracting a third to the n plus 1 like this. Then yadaro manje. Let us now do our calculation. Tikati 3/2 subtracting 0.001 inobuda iri chi? Inobuda iri fractionally 1499 over 1000, which is less than. Then kunoku tinogona kuda kubvisa. Alright, katungenyora yakadaro 3/2 1 minus a third to the n plus 1 like this. Then manje takuda kuchibvisa chi? So ndikuita dot multiplication. Tada kubvisa part ya 3/2 to multiply ne conjugate which is 2/3. Ma 2 akachekana, ma 3 akachekana, kuno kutoita the same 2/3. Saka tikada kuita that calculation 2/3 it's 2/3 multiplying 1499 over 1000. Tinowana 1499 over 1500 like this, and this is less than 1 subtracting a third to the n plus 1. Saka tikachinjanisa negative ikauya kuside yukova a third to the n plus 1 and it's less than 1 inoramba iriko yoti minus 1499 over 1500 kureva kuti panapa it's a third to the n plus 1 less than. Tikati 1 subtracting 1499 over 1500 tinowana 1 over 1500 like this. Then kana takuda kuziva kuti n ndiani, of course takuintroduce the natural logarithm ln cannot ln, indi not ln, laugh all you want. Saka panapa ikadzika according to laws of logarithms inova n plus 1 ln of a third less than ln of 1 over 1500. Saka n plus 1 ingeri less than 1 ln of 1 over like this over ln of a third. Saka let me evaluate my natural logarithms at now. 1 over, I'm in my calculator like this, dividing the natural logarithm of a third like that. So what do we get panapa? Ngatingoisiya yakadai so. Kana kuti tikai evaluated according to my calculator iri kuti n plus 1 less than ln of 1500 over ln of 3. Saka panapa n plus 1 yakwenda kuside uku, so it's n less than ln of like this over ln of 3 subtracting 1. So let me see kuti ndikadai so ndikati subtracting 1 ndinowana as a decimal answer ndiri kuwana for n is 5,2, 3 decimal places 656. That is the answer I'm getting. But remember kuti n should be representing number of terms. Saka we cannot have a fraction of a term. For that we round up. N is equals to 6 is going to be the answer. So that is our answer there. So n is equals to 6. You don't have to forget that you have to round up because n murukutsaga number of terms. That is what we have to do. Let us now take on our number 3, part C, so that we see what we have to do. Saka, when we look at C, two sequences are defined for n is equal to 1, 2, 3, and so forth. And Saka, that is the first fact we are told that we have two sequences which are defined for n is equal to 1, 2, 3, and so forth. So chakadefined, it's n. N represents positions in a sequence, and ultimately n will represent a number of terms in a sequence. But on an individual scale, n represents ranks, positions in a sequence. That's why tikati u4 tukureva the fourth term, n inge represent a position number 4. But kana iri n iri pa summation ndo inge represent the totality of all terms in a sequence. Okay. So the two sequences at Tapiwa panapa, what are they? The two sequences are the nth term is equal to n plus 1, n plus 2. Taudzwa kuti v of n, which is also a type of the nth of 10 of the, which is also a type of the nth term. Vn is equal to 3 subtracting a quarter to the n, like that. Saka zvakunzi describe the behavior of each of the sequences as n approaches infinity. Saka tikatarisa manje apa tinoona kuti tikati un and is equal to n plus 1, n plus 2. Tinoona kuti this is a diverging sequence. It's a diverging sequence. Divergency iri kubva papi? Iri kubva pakuti tiri kubva tikatora, for example, the first term, and let us do it because we atifanira kungoita maconclusions atinenge tisingazive. Saka the first term panapa inenge iri chi 1 plus 1, 1 plus 2, which is 2, 3, saka ndi 6. Second term inenge iri 2 plus 1, 2 plus 2, 3 times 4, that's 12. Saka the third term inenge iri 3 plus 1, 3 plus 2, 4, multiplying, that's 20. Then u4 inenge iri 4 plus 1, 4 plus 2, that is 5, 4, 5, 6, saka 30. Saka mukatarisa sequence yatiri kugadzira panapa, ndi 6 12 20 30. Saka it's obviously a diverging sequence. Saka muchaona kuti divergency kana kuri kuma sequences, it's a phenomena that's the norm. Sequences diverge. That is the normal of sequences. Ma sequences akawanda, they are diverging. So from a realization that we have a diverging sequence, we are also going to see, let me make the conclusion, then we show how we are arriving at that conclusion. Tichaona kuti Vn is equal to 3 minus a quarter to the n is a converging sequence. Saka convergence iri kubuda papi? Convergence irapa V1 inge equal to 3 minus a quarter to the power 1, and which is 3 subtracting a quarter, yatinogona kunyora is what, 4 8 12. Saka 12 over 4 subtracting a quarter, we eventually get 11 over 4. V2 inenge iri 3 minus a quarter squared, which is 3 subtracting 1 over 16, which is, what is 16 times 3, Garajan? 16 times 3 in the 48. Saka hapo inenge 48 over 16, subtracting 1 over 16, kura kuti answer yatirikuwana hapo it's 47 over 16. So tikatora for example 11 over 4e, tika evaluate as a decimal, 11 dividing 4, tunaona kuti it's 2.7 ton. 11 dividing 4 tunaona kuti ndiani ndi 2.75. Tikatora 47 over 16, 47 over 16, tunaona kuti it's 3.615, and over 16, I'm sorry, calculator mangu that over 13, that brain zangu tsatsa kuti hazvisi make sense. Tunaona kuti it's 2.9375. Saka mukatarisisa muchaona kuti from these two numbers alone, what are we approaching? Tiri kuapproacha 3 in infinity. So it's a limit to 3 just from those two. Saka why is it important to know that this is converging, a converging sequence, this is a diverging sequence? Why is that important? So after tawana one diverging, one converging, we go back to the question. Two sequences are defined for n equals to 1 to 3 as follows, handwriting. Describe the behavior of each of the sequences as n approaches infinity. Saka patatu taura panapa kuti un is a diverging sequence, ingetori answer because kuti diverging sequence ndiyo behavior yacho. Patati this is a converging sequence, answer because kuti converging sequence is also a behavior. Saka vabhaiza pakuti as n approaches infinity, kureva kuti vari kuda a summative behavior. Saka kuti mu-understand a behavior, the same way method yamunoshandisa ku-understanda kutsvaga kuti city an AP or a GP is the same method you use for behavior. Munotsvaga the first few terms, then you use evaluations to know. So taona kuti un is diverging because iri kutangira pa 6 and it's continuing towards infinity without converging anyway. But taona kuti Vn is converging because iri kunanava, iri kuswedera pana 3 by every term. Okay. Let us now go to the second part. So this was part 1. Let us now go to the second part. Second part here could express un plus 1 plus un in terms of n, simplifying your answer. Saka tiri kunzi express un plus 1. This is 2 marks. so un plus 1 chi tinoda kuziva kuti un plus 1 inenge iri equal to chi, un plus 1 inenge iri equal to, saka panapa manje tikadzokera kumusoro taudzwa kuti un is equal to n plus 1 like this, handidi it's un kwanzi iri equal to n plus 1 n plus 2, saka un plus 1 inenge iri equal to pana n pese tichaisa n plus 1, saka apo inenge yachi tokondosa bracket tot n plus 1 kureplace kana kusubstitute n dot plus 1 tozoti n plus 1 plus 2 like this. So a simple evaluation panapa inenge chingoti n plus 1 plus 1 n plus 1 plus 2, so this is n plus 2 n plus 3 like that. So that is what we are getting there. Then un, because times t evaluate in our question, the question is saying we have to evaluate. Let me write a question in a different color. Question iri kuti evaluate un plus 1 plus un in terms of n simplifying your answer. Saka un plus 1 taona kuti chi, so panapa un plus 1 it's chi n plus 2 n plus 3 plus un ndio chi n plus 1 n plus 2. So what we have to do up, we just have to expand brackets, but before we even expand brackets there's a clever way. Terms edu anoseparatwa nema-arithmetic operators plus na minus, saka we can factor out n plus 2 panapa, uko teta kusara tina n plus 3 plus uko kwenge kuna n plus 1 like this. Saka apo it's n plus 2 like this. Yova yeta se tovatati umumuteta kutishi n plus 3 plus n plus 1 like this. Saka this will be equal to n plus 2 2n rather plus 4 like this. Indo inenge final answer yedu. Takadzokera ku question zvakare yandotarisira kuti mune pamaikopa. Express un plus 1 plus un in terms of n simplifying your answer. So this is expressed in terms of n. Mukaexpanda iyi, strictly speaking answer yenyu inenge isiri correct, because tikaexpanda inobuda iri 2, akandinyora with a different color. Tikaexpanda inobuda iri 2, it's 2n squared plus 4n plus 4n plus 8, which is 2n squared plus 8n plus 8. But question yati in terms of n, iya is n, en squared. Saka CI answer yenyu yakadai so. CI answer yenyu yakadai so. So this is summatively what you expected to do. I hope pamakagona, congratulations. Pamsonanyazo kugona, you make corrections of what you did. If you have any questions, please don't hesitate to ask. You want to join our school, WhatsApp us on the numbers which are going to show on your screen in a moment. Thank you and take care.